we got a summit of a mountain this many meters above base camp. Measured to be this horizontal from camp in this direction, west of north. And what are the displacements? Ah, we already know Z, right? 2060 meters. Because Z is straight up, and they tell us it's that far above base camp. So, yay! We have one of the three answers. If we draw this, draw a plane here, with this being north and this being west, they're saying in that plane, we go 38 degrees west of north, so that would mean this angle is 38 degrees, and then we go directly up from that, so of course that would be a right angle here, that we hit the summit of our mountain. The Z direction there being 2060, this being 4520 meters, and then the green line is our displacement, our three-dimensional vector. Yeah. Yeah. That's in the Z plane. So if my hand is the horizontal plane, it's in the Z, it's the marker. Yeah. So X and Y, fairly straightforward, right? Or very straightforward. You have the hypotenuse, you have one of the angles. So you've got the hypotenuse, for me it's 4520 meters. We have 38 degrees, and so this side would be 4520 meters cosine 38 degrees, and 4520 meters sine 38 degrees. My guess is they're considering north to be positive and east to be positive. So my guess is they're looking, those that finish this one, were they looking for positives or negatives there? The X value was probably the negative. It's going to be negative. Now, if you guys haven't learned, website actually will do some of the simple math for you. So I don't think it'll do the trig function for you, but if you have like 5 times 5, you can put in 5 times 5. To figure out the magnitude of this displacement, you're just going to use the fact that it really forms two triangles that share the hypotenuse of the first triangle, this blue triangle, is one of the sides of the other right triangle that includes the height, the altitude. Therefore, so if you did D, you're going to end up with that D squared equals X squared plus Y squared plus Z squared, where X and Y really come from sides of the blue triangle. In a sense, it's a 3D form of Pythagoras. The other way to look at it is that the hypotenuse of the horizontal triangle is the side of the vertical triangle, and this X plus Y is the hypotenuse squared of the horizontal triangle, which becomes just one of the sides of the vertical triangle. Yay! Questions? Did you put in positive or negative? That's why. It's pointing west, which all you need to do is put in the negative of it. Any other questions, comments, helps I can give on this one? All right, number 13. Small battery powered electromotive boat can travel at this speed, still water. It's operating on a river. So you guys realize the code from last year, right? If it can do that in still water, that means that's the magnitude of its velocity always against compared to water. Yes. So still water really means in the reference frame of the water. It's just another way. It's a common way of saying it. It's operating this for each following two cases. Determine the requested information river that is this many meters wide. So good. We're back to meters per second and such, not that nasty meters per minute. Straight across the river, determine the speed viewed by someone on land. So downstream before reaching the other side, and the time t takes both minutes. Okay. So for A, we just have velocity of the boat with respect to the, do I call it river or water? Water, okay. Plus the velocity of the water with respect to the shore will give us the velocity of the boat with respect to the shore. And they want to know the magnitude of that. I know this, right? This is my 1.55 meters per second. I know this one, 1.45 meters per second. And so I can find my velocity there. And so magnitude, and I would suggest you're finding the direction also theta. Because then I'm going to also remember that my velocity and my displacement are in the same directionality, right? So my displacement d across the river is 226 meters. This would actually, I'm going to call that dw. And this would be d boat to shore. And of course, there's similar triangles, so that is also theta. And you can also even think about it as the link between the two is the amount of time, right? So if I wanted to know, if they asked me the distance downstream, I think it'd be easier to probably figure out the time it took and then figure that out, because I can look and say, oh, it traveled 226 meters straight across. Its straight across velocity in the direction of that displacement is 1.55 meters per second. Oh, I can figure out the time for that, right? Just using v is v delta t, and so figure out the time from straight across, use that as my velocity of the water with respect to the shore to figure out the displacement of the water. Ready to go on to part B, or do you need a minute on part A? I couldn't hear, sorry. One more minute? Okay. For which one? What do you want to find out? Stream, that'd be dW. So in that case, you'd be looking for it, but you know the velocity in that direction. And so you need to also know the time code. Yep. Nope. The velocity in the downstream is just the velocity of the stream. The boat's velocity does not contribute to the perpendicular to each other. Now, in the next case, they do contribute to each other. When we're ready, just give me a high sign and we'll go. Probably pause. All right, moving on to B. So now the boat operator wants to go directly across. And come on land. That's really important. So now, this is the velocity of the boat with the shore. That will be the velocity of the boat with the water. And that's the velocity of the water with the shore. So the person on the shore, are they going to see the boat moving faster or slower? Slower. Slower. And then, of course, we have, so it's beta that we want. We know the same two. Again, with our displacements. I'll call that the water. Right, and then very similar, we just have a different triangle now. Right? Because now with the 1.55 being the hypotenuse, it's going to take us a different amount of time and everything like that. Still a right triangle, still same type of trait. Alright, so number 5. We get this projectile, the edge of a cliff, above ground level, this, angle of this, as shown in this pretty little figure. So determine the time for the projectile to hit point P on ground level, determine the distance x, point from the base of the cliff. Oops. At the instance before the projectile hits P, find the velocity. And for this point P was the magnitude. Oh, so that's just combining those, right? The instant before the product, the angle made by the velocity vector. Oh, then just do the tan. Find the maximum height above the cliff reached by the projectile. What's going to be true at that maximum height? Vertical velocity equals 0. So I'd say the first thing, we could do it all just keeping it in vector terms, but let's go easy. Let's go and do x and y. So in the y direction, we're starting our d sub y naught is h, for me, 185 meters. Oops. I would introduce a little bit of error. I'm going to take the origin to be at the base of the cliff and upwards and to the right is positive. Is that okay with everyone? Kind of go by convention here. But, so that means dy final is going to be 0 meters. V initial, Vy initial, if I think about, there's my V initial. I'm going to have these two components with an angle of 35 here. So that would be whatever my V is, 115 meters per second times sine of 35 degrees. My AY is going to be negative 9.81 meters per second squared. I think that's about all I know about Y. My X, dx naught is going to be 0 meters. The X final is a mystery. The X is going to be my 115 meters per second cosine 35 degrees. Of course, I don't have any acceleration in the X direction because we're talking about a simple projectile here. And I know they share a common delta time. Right? So, in their questioning, they're actually trying to lead me through how to do this. All right? So, time-wise, X doesn't have a lot of variation with time, but Y does. So, generally, my approach, unless there's a limiting condition in the X direction, like it hits a wall, it has to pass over something, some type of limiting condition, X isn't going to tell me a whole lot about time. Y is usually my default to think about time because I know a lot about it. So I'm going to use our good old friend, D equals D naught plus V initial T delta T. Delta T plus 1/2 A delta T squared. And I know D naught, that's Vy naught. I know D final, that's 0. I know V initial. I don't know delta T. I know A. I don't know delta T. Solve. Find my time. Now I'm armed with the time. So now I can do the exact same thing, but this time in the X direction, where I'm looking for D. I know D naught. I know V. I know delta T now. I can forget about the rest of the equation because I don't have any acceleration. Yes, yes, kilometers. Yay, I helped him. You guys want me to keep going how to do the other part? Okay. So C, we're going to have horizontal vertical conditions. So if I was to draw what it would look like, it's going to be coming down like this. Now, this is where I'm going to look ahead. What angle is made by the velocity vector with the horizontal? So I'm going to pick to represent my vector this way. That way I don't have to redraw it when I want to do question E. So this would be V. This, of course, is that value. This is going to be V final Y, which I don't know. But I know that V final equals V initial plus A delta T. I know A, I know delta T, I know V initial, I can find V final. And then plug those in, Pythagoras for D. right? Z squared is going to equal Vx squared plus the final y squared. I would use that if we call this angle alpha, I would use that the tan of alpha equals the final y over dx. And then for the bottom part, I would probably go with that v final squared equals v initial squared plus 2a delta d. Do it in the y direction, so I'd end up with 0 squared equals v y initial squared plus 2 times a y times h. Sorry. Times h. I need to see my diagram again. Because they're not actually, yeah. They want to know the height above the cliff top. So they want to know, let's call it, what do we want to call that height? How about H max? So that delta D is going to be the 185 meters height of the cliff plus H max. And H max is the only thing you don't know in there. Yay! All right, we're going to go for number 12. For the three-dimensional vector of this, determine the plot. Were you guys able to do the magnitude? Yeah, it's x squared plus y squared plus z squared square rooted. The angle between the vector r and the positive x-axis. Okay. So, positive x-axis is this way. Now, what I'm going to do is I'm only going to look for this one, for B, I'm only going to look at the part of this vector that's in the xy plane, which is the 1.5i plus 2.86j. So there's my positive x-axis. Got a component 1.5 in that direction, a component of 2.68 in that direction, and so my vector is in that direction, and I'm looking for alpha there. So I would use that tan of alpha is opposite 2.68 over 1.50. Now, what's the biggest danger when you're working with angles? Radians versus degrees. Just make sure they're asking for degrees, so make sure you're in degrees when you're doing it. The angle beta between the vector r and the positive y-axis. Oh. Okay. Let me make sure I'm not screwing it up. You never know. Wow. Where does it ask positive x-axis and positive y-axis? I'm just having a thought. Because, let's see, are they thinking, you guys are getting that wrong. Our vector actually points in that direction. Are they thinking, because it's weird that they'd ask beta, because alpha plus beta is just 90. Since we're up here into the 3D plane, I'm wondering if they're thinking of that vertical angle rather than the angle in the XY plane, the angle in the XZ plane. So if they're thinking XZ, try this, try that tan of alpha equals 3.12 over 1.50. And it could be them or it could be me. Okay. You got it. All right. So, the reason we were getting this wrong, and sorry, I was thinking two-dimensionally also, not three-dimensionally. So, if we think about it, there's really two angles here. Is that us? Well, remind me